So whatever we do going forward will be recorded. Interesting information, which is this email, ml@mcal.in. We are always available to answer your questions. If you have any questions that you might have, or you come up later after the webinar and you thought that I should have asked this and you couldn't ask, use this email address to reach out to us, and we'll be happy to get back to you within 24 hours. And I usually forget emailing the deck. So, at the end of the webinar, feel free to remind me. If you want a copy of this deck, just ping it. I will make sure that I send out the PDF version of the deck for you all to refer and use it for your reference. A quick introduction to MCAL Global, which is the organization that I am representing right now. We are a training company, and we have been in the training industry for more than 7 years now, and we have trained more than 10,000 professionals across the world. We have close to 50 international clients in Asia, Middle East, Asia Pacific, and in US domestic, we have a lot of clients that we cater to. All of our clients, we did a feedback. We regularly keep doing feedbacks, and 95% of them give us excellent or good feedback. And most of our business runs on referrals. We get a lot of referrals from people who already join our course. A quick note about me: I'm Sridhar Anand. I'm the presenter. I'm one of the co-founders of MCAL Global. I am a mechanical engineer by profession, but I have, over the last 17 years of my life, worked in IT, and I have off late jumped on the bandwagon of artificial intelligence, machine learning. I believe in this technology. I think it has a lot of potential, and in the future, we are going to see massive social changes because of this technology. And it's better to know it now and be on the winning side rather than on the losing side. All right, let's do a human versus machine comparison, right? So what is a human, right? Humans are biological beings or animals in a way with refined consciousness, but we essentially look and experience things around us, and based on that, we learn. Whereas machine is just designed to follow instructions. Whatever instructions you give to the machine, that is exactly what it executes. And these two are a striking difference between humans and machines. The question that we need to ask ourselves is, can machines, like humans, learn from experience? This is where things starts getting very interesting, and we jump into the world of artificial intelligence / machine learning. So what is machine learning? If you look at the textbook definition, it says, machine learning is a type of artificial intelligence that provides the computers the ability to learn without being explicitly programmed. So when I read this for the first time, it didn't make much sense to me. Type in the chat box if this makes sense. Yes, no, or maybe. I would like to get a quick check of what do you guys think of this definition. Same. Yep. So some people are saying yes, some people are saying no, some are saying somewhat. So folks in the yes, I think you are pretty, I would say you are one leg up. You definitely have been reading about it, have been following it for some time. People about somewhat is somewhere in the middle, and people who said no are like me, who initially when saw this was like, what the hell is going on? So I have my own definition. The way I see or understand the difference between a traditional program and a machine learning is like this. A traditional program is a set of instructions that is designed to take input data, and it takes the input data, churns it, processes it, and gives an output data, and that's pretty much it. That's all programming that we do. This is what every program does. Whereas machine learning, it takes input data, it starts reverse engineering the input data. It starts understanding what is going on in this data, what is the trend, what is the pattern. And as an output, it gives a program. It doesn't give output data. It gives a program, a traditional program, which can now take new sets of input data, data that the program has never seen before. And using that, it can make predictions or give you the output data. So this is where machine learning starts deviating in a very interesting way than a traditional program. Does it make sense? Questions? People are messaging, yes, it makes sense. Great. You can also message in public. There's nothing secret here. But so Tabish asks, what is the output program? What is the output program? Perfect. So for a second, forget about machine learning, right? I would like to go back, right? Just look at this traditional program, right? This traditional program is something that is written by human beings. Human beings, know exactly, what problem they are trying to solve in the current programming languages, and they code their set of instructions saying, I want to do this, and then once this happens, go ahead and do this. It's like a step-by-step instruction that you give to the computer. Now, that is a traditional program. What machine learning does is it takes input data, it analyzes it, and as an output, it gives this traditional program, which otherwise would have been written by a human being. So for a machine learning output, you don't need a human to analyze the data to come up with this traditional program that you would have done otherwise. So it's kind of replacing your brain. It is kind of replacing you as a programmer. It is figuring out how to process this input data and is actually building the program that is going to further process new sets of data that it has not seen before. So that's that output program here that machine learning gives. Does that make sense? Cool. Awesome. So let's keep going. So machine learning algorithms, there's a taxonomy, or there's an organization, the way in which the algorithms have been organized. And you should know this to be able to put what you are learning in the right place so that you get a good bird's eye view of what's happening, right? So machine learning has, at a high level, two types of algorithms, right? First one is called supervised learning, and the second one is called unsupervised learning. So there's a difference between these two. So supervised learning is a family of algorithms that is designed to make predictions, right? So if you are, let's say, creating a program or a machine learning model which is going to predict the price of Google, let's say 6 months down the line. So your intent of that machine learning using the past or historical data is to make a prediction in the future, right? So your intent is, I want to know how the future looks like. So if that is your intent, then you are essentially going to use a supervised learning family of algorithms. Whereas in the unsupervised learning, if your intent is not to make prediction, but to understand what is going on, what are the hidden patterns and hidden trends in the data, I would like to know. It's not that I want to make a prediction. I just want to know of what's going on. And I will use that later on to make business decisions, to optimize my process, or to increase my revenues, or to cut my costs, right? So there are two different subtle different types of use cases under machine learning that exists. Now let's further deep dive into each one of these, right? So supervised learning also has further subclassification, right? There are two categories of algorithms within the supervised learning. One is called classification, and the other is called regression. Now we learned that supervised learning is all about making predictions, right? So what is the difference between classification and regression? We are making a prediction either way, right? There's a difference. So regression deals with, or regression suite of algorithms deals with making predictions where the outcome or the output that you're trying to predict is a number, right? The share price of Google 6 months down the line, or the house price in Boston 3 months down the line in a particular zip code, or the price of gold, 3 months down the line. So these are all numbers. It could be any number on the number line, right? There is no finite set of uh, uh, values from which you're going to make a prediction on, right? It's infinite. So it's a number. So that's when you use a regression. Whereas on the classification side, you are making a prediction of where the predicted value, that the prediction that you're making is a finite set of value. It's like a yes and no, or it's a yes and no, and maybe. So for example, you have the blood results, right? And the hemoglobin content in blood, the sugar level, the A1B value, and all those blood results are there. And using that blood test results, you're trying to make a prediction whether the person is diabetic, yes or no. So this is a classification, because the outcome that you're trying to predict has only one of the two values, yes or no, right? So that is the difference between regression and classification. Unsupervised learning also has two different types of things going on under its umbrella. One is called clustering. So clustering is a suite of algorithms that essentially tries to figure out the groups, the logical groups or clusters within your data. That is, are there any holistic trends around which the data points are clustering or coming together, which means, for example, Amazon, which is selling, millions of products in a month, right? And folks in Amazon would want to know, are there any trends in terms of, let's say, people in the age group of 20 to 30 who are living in New York, who are male? Are they all clustering towards a particular product? I mean, is there something that cuts across this set of dimensions or parameters, right? So clustering starts showing those kind of information in the data. The other technique in unsupervised learning is called principal component analysis. So what this does is essentially it helps you figure out noise in the data. So in real world, when you are capturing a lot of data points, not all data is going to be key in making a prediction, right? So for example, if you're capturing the data point when you're going to wake up in the morning, and if you're trying to correlate that to the GDP growth rate of US that you're trying to predict, those two values don't kind of correlate directly. I mean, if everybody wakes up late in US, then yes, the GDP will be lesser. But jokes apart, what I'm trying to say is that there will be noise in data. There will be data points that will have no bearing to the outcome that you're trying to analyze or predict. So in order to remove noise, things that are going to clutter your table, and remove remove them from your analysis to make it more efficient, faster, you use a set of techniques under principal component analysis to make your data more pristine. And then maybe you can, after doing a principal component analysis and removing unwanted features from your data, then maybe you might want to feed the data into supervised learning and do your predictions. So this is the lay of the land in machine learning algorithms. Whatever you're going to do is going to more or less fit in one of these buckets. There are new things coming up. It's still an upcoming field, but 99.99% whatever you will do is going to fit in one of these 4 low-level buckets on the right. Questions? Any questions on this slide? All right. No questions means I'm doing a great job or I'm doing a very bad job. Okay, good. We have a question. So Daniel says, can you give me another example of regression? Sure. So one example of regression that is a classic case is you want to make a prediction on the house price. So you are planning, you are a real estate investor, and you want in your portfolio to build a set of real estate properties, and you are trying to figure out, you have, let's say, 5 properties or 5 options that you think you have zoned in, or 100, depending on where you're coming from, which company you represent, individual company or whatever. And you need to make a decision on top 3 or top 2 or top 1 property that you're going to invest your dollars in. So regression is used by real estate investment firms as a technique to take all the available real estate properties that they have at hand, use the data, historical data, use the current data of economics, GDP growth, use the current data of the zip code where they are in, and build a model and try to predict what the house price is going to be in next 3 years. So let's say they want to build a portfolio, invest now, and cash out in 3 years. So they want to do a robust analysis and figure out which are the properties, which are the assets that they need to invest their money in, which is going to give them the maximum return in the next 3 years. So they use regression on each one of the available properties and try to make a prediction 3 years down the line, which are the ones are going to be at what value. And then based on that, they're going to pick the top 2, top 1, top 5 based on their budget and go ahead and execute the deal. We're talking about real money here using these techniques. Did that answer your question, Daniel? Cool, awesome. So another question is, do we need any structure to the data? Yes. So think about these things. A very natural question to ask is, when do I use machine learning? How do I know that I am in a situation where machine learning is going to help? So the first question that you need to ask is, the data that I have and the outcome that I'm trying to predict, there is some correlation between them or not? Are they related or not? I mean, you have to believe that there is some correlation. You might not know what the correlation is, but you have to believe that there is a correlation. If you have that feeling, then yes, you have satisfied the first criteria of machine learning. The second criteria is, you have a feel that, yep, there is a correlation, but you have absolutely no clue of what that correlation is. You don't know. You don't know that exact correlation, exact thing that this input has towards the output data. Because if you knew the correlation, then there wouldn't be any need of machine learning, because given the input data, you would be able to exactly tell what the outcome is going to be because you know the exact correlation. So the second constraint that needs to be fulfilled before machine learning is you should not know what that correlation is. Only God knows at that time. And then the third and the most important criteria that needs to be fulfilled before you can do machine learning is you need to have a lot of historical data on which you can start training and learning your machine learning model. It's just the equivalent of experience. Just like human beings leverage the experience that they have gathered to make new decisions going forward, machines also need a lot of data to be able to learn and create a brain using that, a model, and use that to make predictions. So these three conditions need to be satisfied. Once these three conditions get satisfied, you are in business of machine learning. So Ariel says basically use statistics, correlation, volatility with all combination of data to calculate final. Amazing, amazing insight. Yes. So if you look at the regression techniques and a lot of classification techniques and also unsupervised learning techniques, statistics is the core. It is the rock foundation of machine learning. That is something that machine learning builds on top of, but there is much more to machine learning. There are certain techniques which are not statistical in nature, like a decision tree. It's a model that you can't, it's not a formula. There's nothing that you can write in a one line saying this is the formula that is being used to correlate the input data with the output, or neural networks that you want to build, right? It's a thing, you cannot explain it, but it somehow gives the right predictions. So there's a little more to machine learning than on top of statistics than just statistics. All right, let's go and do a real quick quiz to see how much of this has stuck. So I have 4 scenarios on the left, and you have to tell me in the chat which category of algorithms do they belong to. You can type R for regression and C for classification. So if I'm trying to build a model to predict whether the email is a spam or not, what kind of algorithm or family of algorithms would I use? Cool. All of you got it right. It's classification. Absolutely correct, because we are going to make a prediction of yes and no. Yes spam or no spam. So that is classification. So we want to predict the stock price of a stock in the future. Which family? Cool. Yep. Yeah, so all of you got it right. Amazing. We use regression because it's going to be a number. I need to predict the house price based on the different data points or attributes that I have collected. What? Okay, cool. Good. All of you got it right. Everyone. Yes, it's going to be regression. Absolutely right. I want to make a model that predicts whether a person is diabetic or not based on the blood report or the blood data points. What is it? C. Absolutely correct. Yep, you all got it right. It's classification. Absolutely right. Great. So you guys get the concept and understand the difference between regression, classification. Awesome. Let's move ahead. Let's look at some applications of machine learning. I'm not going to go very much deep into this because I can go on and on this. So social media uses machine learning heavily. be careful when you are liking or sharing a post, or sending smileys, or thumbs down, thumbs up. You are giving your DNA or your build, what you think, to the social media, and it now exactly knows. It can start predicting which are the things that you're going to like, which are the things you're going to hate, which are the things you're going to share. So it's going to feed you more of that. So that's where social media, search engines, healthcare is using. Tabish said that is how I got through here through Instagram. Yeah, there you go. There you go. Ariel says same here, because you might be liking, sharing, reading about machine learning. It knew that this is the person that I need to show this particular event. So there you go. Not all bad. Absolutely not. No, absolutely not. So healthcare is using. IBM has come up with their own machine learning platform. It's called Watson, and it is being used, heavily in healthcare to to create care management programs for patients. It's pretty amazing. Banking and finance are using it, amazingly. Stock trading, hedge funds, figuring out which products to sell, which customers. It's mind-boggling how much how much banking and finance are utilizing machine learning. Legal services, there are predictions that after some time you would be able to interact with a machine to get all legal advice, or most of the legal advice. Retail, I just gave an example of Amazon a little earlier, right? All the recommendation engines that you see in Amazon or Walmart or Best Buy, when you go online and try to buy, it says in the bottom, oh, if you bought this, you might also want to buy this, right? It's all machine learning. Public services, 911 calls in US. Some centers are experimenting with machine learning and trying to triage the calls, and figure out the priority of the call based on the issue that is brought up. That's pretty amazing in cost savings and promptness of service. Security is another area where machine learning is heavily used, because everybody has realized a it's a cat and mouse game. You cannot be ahead of the hackers. So hackers are always going to be one step ahead. All you can do is speed up your reaction time, right? You can how quickly you can close the hole that the hacker finds. So machine learning is being used to figure out anomalies in access, anomalies in network. And because it's looking for patterns, it knows what are the patterns it should expect. Whenever it sees a deviation, it immediately raises an alarm, and there are people who jump on it, analyze it, and fix it. And that's how you can be very, very proactive. Can machine learning also be used to hack? I'm pretty sure, if smart people sit and think, they will be able to leverage it for that. But I highly, highly recommend all of you who are here in this webinar and the tools that you're going to learn later on to use it to make the world a better place. This is a very powerful technology. Use it, use the superpower with responsibility, and use it to do good things in life. So all the data that these different use cases of machine learning are using, it's being converted into information, and then you can, using that, give better digital services to your customers, better products, targeted products, and also information driven systems which are very tuned to the user's needs. So an example of how LinkedIn uses, a typical LinkedIn profile looks like this. LinkedIn knows the designation you have at a particular company. It knows what is your location. It knows how many followers you have. The bigger the followers, the important the person you are. It kind of knows what your education level is, what field you have your education in. It knows the posts that you're liking, sharing, or interacting, engaging with. Now, these are all data points that LinkedIn can very, very effectively use to give you better digital services. It can show you people that you might want to connect with, or people you might already know because of co-location. People living the same area might have gone to the same school, trying to like the same thing. So it can use that to provide better digital services and also data products. Google, many a times when you start typing and it tries to complete your auto-populate, and sometimes it feels like it's reading your mind. That's also a classic case of machine learning, right? You start typing your keyword, and the autocomplete is started gets supplied by a machine learning model that is constantly learning, right? And it is updating, and the important factors that used by these models are: what is the query volume, right? What is the popularity? What is the geolocation of the user where the query is coming from? What is the time at which this query is coming at? Or what are the keywords, importance of those keywords on the web, right? And based on that, it automatically gives. And sometimes it's doesn't behave correctly. It gives wrong data. It uses you as a user to perfect its algorithms. Look at this: report inappropriate predictions. It even uses the word predictions. And there are people who see a junk here, they click this, and Google knows that this was a bad output, and its machines automatically corrects itself and continues that refinement. Imagine billions of people feeding data and correcting Google. It's no wonder it feels like it's reading your mind. There are other examples of machine learning that are picking up, right? This classic case of email spam filter, they have gotten better over time. Right now, everyone uses machine learning. Now, stock price predictions, machine learning all the way. Facial recognition, and Facebook uses it, or many other companies have started using it. It's all machine learning. Voice to text. People from different parts of the world have different accent and different way they speak, different stress points. Machines have been trained to pick all those variations and convert it to text. Law bots, like all the legal dispositions that have been given by courts, have been converted into models, and you can go and ask questions, and it can start giving you advice based on the data that you give. It can tell you it's a felony, misdemeanor. These things exist as we speak. Autonomous cars, the mother of all AI application. There are many cars already there. A couple of weeks back, I shared a post in LinkedIn where it showed Domino's delivering pizza in an autonomous car. And that was an experiment, but it showed how a car all by itself comes in a subdivision, greets the person, delivers the pizza from the window. People sign it off on the credit card machine on the left of the window, take the pizza, and the car goes. There was no driver, nobody. Now imagine the socio economic impact of this thing. It's a revolution waiting to happen in the next 10 years. And think about what the government is going to do, how they're going to react to all the people who drive trucks and cars. What are they going to do from a perspective of job? How are they going to earn their living? Ford and GM, they are selling cars, and you and me are buying cars. Will people buy cars 10 years down the line? Are my kids going to buy the car? I don't know. So there's huge changes that we need probably legislations around to manage. So let's switch gears and let's start talking about Python. So in order for you to do all those cool things, you need a basic programming language to go along with you to kind of pull those things off. And we recommend you go for Python without even thinking twice. This is the language of data science, and I'm going to convince you why you should go and use Python and invest your time in Python if you are into data science and machine learning and AI. First of all, it's an open source, free to use language. You can download it, install it, and everything that you create using this language is your intellectual property. and you don't have to pay any license fees to anybody. Second, it's very quick to install and write your first program. And for you to get started using this and quickly get started, it'll be like blazing fast. You can do it. If you have a high-speed internet connection, you should be up and ready in less than 10 minutes. It has a very simple syntax. The way Python has been designed is it's not verbose. It eliminates unwanted typing, is very simple, close to English, and gets the job done. So let's look at a quick comparison of what the simple syntax means, right? On the top, there's a Java program. People who don't know programming, don't worry. All this Java program does, 5 lines, is just prints hello world on the screen. That's it. Just to print hello world, you have to write all these crap 5 lines to get to that output. But in Python, all you have to do is say print hello world in your program, and it prints hello world. None of the verbose things as you see above. So it's very simple syntax. It's very easy to follow. And you don't need to be a Python expert to do machine learning. You need to just know 3 or 4 basic things, and that's it. You're not creating a web application using Python. You're not doing any RESTful web services using Python. You don't need to learn all those things in Python. You just need 4 or 5 basic things that you need to learn. That's what you're going to leverage for machine learning. And we're going to see later down what those things are. And those things are these out-of-the-box libraries. This is what makes Python very powerful. So there is a library called Pandas. It exists out of the box. And it is essentially your Excel-like capability, multi-dimensional array, and rapid queries in that within your program. There's NumPy. Pandas is built on top of NumPy. This library helps you handle multi-dimensional arrays for scientific data. There's Matplotlib. It helps you visualize data. You can see data. There are amazing set of capabilities here in the different capabilities that you have in terms of visualization. It's mind-boggling. It's all free. And then there's the scikit-learn. So this library has all the machine learning algorithms. You remember the slide where we were doing the taxonomy of supervised, unsupervised, classification, regression, and all that? All those algorithms have been already written as libraries and packaged inside scikit-learn. All you got to do is 1 line you have to write in Python to load the library, and the 2nd line you have to write to pick the algorithm, and the 3rd line you have to write is to train your data, and the 4th line you want to write is read your new data, give it to the model, and make a prediction. In 4 or 5 lines, you will be done with machine learning. That's how simple it is. That's how simple Python is. Python also has NLTK library that is used for natural language processing. It also has adapters to TensorFlow. So TensorFlow is your neural network, a big machine learning platform designed by Google. It's also called deep learning. So just keep that in mind. These are the cool things that exist in and around Python that makes this a #1 choice that you should invest your time in if you want to be a machine learning or a data scientist or artificial intelligence. You can do a Google search right now and check out the popularity of Python. You can do top 5 programming languages, and you're going to see Python in either 1, 2, or 3, one of these positions. So do it right now. Check it out. You don't have to trust what I am saying. Look at Google, see what it predicts. It is one of the top 10 programming languages. It has, in fact, become the de facto programming language for data scientists. Anywhere you go, any group that is doing data science, they'll be all on Python. If you want to get in that group, if you want to get in that gang, you have to learn Python. Otherwise, you're an outsider. Okay, how do you learn more, right? How do you learn more? So I have this link. It's a Stanford published book. It's a free book. You go to the link, download the PDF, and it's called The Elements of Statistical Learning. Somebody early on had mentioned about statistics. So this book gives you a lot of information, a lot of foundational information on machine learning. Download it, please read it, use it. It's a free resource. It's for you. Make the most use of it. The second thing is, we have a blog that we have written, and that teaches you how to learn machine learning from scratch. It first goes in and tries to analyze, help you put where you are in the spectrum, where you intend to be, and then how you map that path. It gives you all the resources you need to do that. The third thing is we do instructor-led live online training in machine learning. You could join that and take advantage of that. The next batch is starting next week on Friday, November 9th, US time, evening. You can join that and learn more. So what is that course that we are offering all about? Our course is a quick primer on Python, just enough to do machine learning, and then the machine learning in itself. We're going to see later what are the different things we're going to learn in machine learning, right? So if you look at the course curriculum, we go through the introduction, we give you a bird's eye view before we jump in. Then we get into Python fundamentals, then some advanced Python. It'll all happen in the first weekend, I would say. And then we start machine learning. There's an introduction. We delve deeper into supervised learning. Under supervised learning, we understand linear and polynomial regression. We understand logistic regression. We learn decision trees, random forests. We learn boosting and bagging techniques. We learn k-nearest neighbors. We learn naive Bayes. We understand support vector machines. And every algorithms that we delve into, we're not going to make you make you create these algorithms. We're going to leverage these things pre-packaged in Python. We're going to teach you how to use them, not write them, but to use them. In which scenario you should apply what algorithm, which are the points where this algorithms will start failing and you need to switch and pick something else. Those are the things we're going to teach you. We're going to teach you how to tune the model that you're producing so that it's most optimum, right? And then we're going to jump into unsupervised learning. We're going to look at k-means clustering. We're going to do linear component analysis. Then we're going to do one project work. And that project work will simulate a real world experience where you would use everything that you have learned so far. And you're going to see how in real life it's not a straight line, how things don't line up, and how you have to go back and forth and back and forth before you come up to the right and most optimum solution. Then we are going to delve into natural language processing. That'll be an introductory course, introductory information, not detailed. And then we are going to delve into deep learning again at the introductory level. These last two points will be at the introductory level because these two are a course in itself. The deep learning course is something that we're going to do mid-December after this current batch that we're going to do on the machine learning. So how does the training plan look like? Our training plan is 6 weeks, and each week we spend 2 days, the weekends, Fridays and Saturdays, US time. And if you're in the Asia, eastern side of the world, it'll be Saturdays and Sunday morning. So there is 5 contact hours with the instructor. We go through all the course material. The instructor explains, like we are having a webinar now. There's a Q&A session. There are hands-on labs. There are heated discussions, and there are interesting discussions, and all those happen. And then we basically do the theory labs as I described, and then we kind of take a break for a week. And during that week, we send out the recorded video and assignments that you need to do. And then we reconvene the next weekend. And the same thing happens for the 4 weekends. So we would have spent about 20 hours of contact time with the instructor. And once this is done, we start week 5, which is going to be interesting. This is where we do the project work. This is where we, learn, use everything that we have used in week 1, 2, 3, and 4, and try to solve a real world problem and see the different problems and issues that exist and how to navigate them, how to troubleshoot, how to actually leverage model tuning, how to leverage optimization, and then come up with the right solution. And then after the project work, we are going to go and do um, in the last week we are going to do deep learning or that TensorFlow thing and natural language processing. So these are the this is how the training is going to look like. So it's going to span 6 weekends, Friday and Saturday if you're in the western part of the world, Friday and Saturday evenings, and Saturday and Sunday mornings if you're in the eastern side of the world. So you can go to our website, mcalglobal.com, and check out testimonials. We have amazing testimonials. People just love our course. What are the requirements if you want to join this course? What are the things you need to have? You'll need a desktop computer, Windows, Mac, or Linux. This coursework is going to walk you through all the installation and setup that you need to do machine learning, so you don't have to do anything or come with anything prepared. If you have prior coding experience, it's always helpful, but it's not a mandatory thing, because as you saw, we're going to go through the fundamentals before, just enough to do the machine learning aspects. Basic level math skills is something that you would need. Otherwise, it's going to be very challenging to understand the concepts we're going to talk about. You need an internet connection because the instructor-led training will be through a GoToMeeting as we are having right now. So you would need that. We recommend you have a mic so that you don't have to type and ask a question. You can directly ask the instructor some things that you don't understand or you need more explanation on, or if you have a problem that you would like to discuss. Who's this course for? I would say everybody who doesn't know machine learning should do this, because this is something going to change our life in a radical way in the next 10 years. But we feel, students who are looking to kickstart their career in data science and machine learning, it's a good fit, or anybody who wants to kickstart their career in data science. There are developers and testers who are doing the traditional programming but would like to know what this new thing is, because it's coming up in their meetings and in their companies, new projects. This is a good course to do for them. There are people who already are doing machine learning using tools like R, but R gets you only to a certain level. It eventually is going to box you in. So you need to make the graduation from R to Python to be able to do legit machine learning, which deals with real world scenarios and complexities. There are BI professionals who do a lot of reporting, a lot of data warehousing. Machine learning is a very natural fit for them. There are business analysts. The concept of business analysts is changing. We are getting into the world where data-driven decision is becoming very predominant. So there's a lot of pressure on the current business analysts to change up their game and also pick up skills of data analysis. And this course is going to help you do that. There are a lot of project leads and managers who are now having to deal with projects that have machine learnings as one of the component, and in order to do a good job, you need to know what this beast is. There are students who want to get into especially on the eastern side of the world, finding it hard to find a job. Doing this course gives them a skill which is unique. Not a lot of people have it. So it gives you a competitive edge if you invest in this course. So what can you do after doing this course? You can use Python as a programming language. You'll be able to use Python to do machine learning. You will understand what machine learning is. You will understand the differences between supervised and unsupervised learning, and all the techniques and popular algorithms of them. You will understand regression, classification, clustering algorithms. You will use Python to process data and build machine learning models. You're going to use cross-validation and other model tuning techniques to increase the accuracy of your model. You're going to lay the foundation for natural language processing. This is going to be very crucial because the largest amount of data in the world exists in the form of natural language. You need to know how to convert that natural language data into something meaningful that can be fed into machine learning algorithms. You're going to also lay the foundation of deep learning. Deep learning is how our brain works and a simulation of that in program. And this is giving of late amazing results with the increasing capacity of computers in processing power and in memory. Deep learning has suddenly become very relevant. What will you understand, right? You'll understand regression, the simple one, the complicated one. You're going to figure out how to use regularization to further improve accuracy, right? You're going to learn about ridge. You're going to learn about lasso. You're going to learn about logistic regression, how to use it in what scenario, right? You're going to learn about logit functions and other techniques behind it, and how to quickly use it out of the box libraries, right? You're going to learn about decision trees. And you're going to learn about what are the bases to build the decision trees. You're going to learn about random forests. You're going to learn about boosting bagging techniques. Um, you will understand what k nearest neighbor is, right? How this classifier is going to classify the data and help you do predictions real quick, right? If you let me go back. So in order to do a k nearest neighbor classification, if you look where my mouse is, you just need, there'll be a few lines on the top to load the right library. But in order for you to build a model, that CLF variable that you see on the left is your model. And all you did is you leveraged this k nearest neighbor classifier already existing in scikit-learn, gave it the inputs, gave it some input parameters, and it built the model for you. That's it. This one line behind the scenes is doing all the machine learning, building the CLF model of the output program for you. The CLF is your output program. And then to this CLF, you can fit new data, and it's going to give you the output Y or the prediction on it. So these two lines, very powerful lines. It's pretty much similar for all machine learning. You can do the magic in a couple of lines. You're going to understand naive-Bayes algorithm, right? How it works and how you can leverage it to do accurate predictions. You will understand support vector machines and how you can create an optimal hyperplane, right? You're going to understand clustering and how to use it, in what scenarios to use it. You're going to understand principal component analysis and get rid of noise and unwanted data from your data set. You're going to learn to do interesting plots, to visualize the data and understand what it means and how to take further decisions on it. These are the cool things that you'll be able to do if you do this course. Um, you're going to learn to use Jupyter Notebook. It's a browser-based programming IDE that we're going to make make you learn that and use that effectively. So you're going to be proficient in that. This is how a screenshot of that looks like. These are the program that you're going to write and execute, and you're going to see the visualization or machine learning outcome results right there in the browser. And you can export this as an HTML, publish it on your blog, and show off the kind of things that you can do. You can share it in social media if you want, share it with friends, take it to class, do a presentation. Very powerful tool. You will understand natural language processing, right? You're going to use NLTK to do a quick hello world kind of a program. You're going to understand deep learning. You're going to understand how to use TensorFlow real quick. It's an open source software library built by Google. It's pretty amazing how it can quickly learn and understand things, especially in processing images. There's a strong support of deep learning community within the community. Let's look at the important dates from a training perspective. The next batch that we are doing is starting on November 9th. And 10th are the first couple of classes. 9th is a Friday, and 10th is Sunday. And this date is from the Western time zone. So if you are in the Eastern side of the world, it'll be 10th and 11th. So right now, our students for the 9th and 10th batch, some are from California. I think some are from Toronto, Canada too. There are some in the Eastern time zone, and there might be few from India. So that's the spread right now for this batch. So keeping that in mind, we have a particular time that we have chosen before we get into the timings. The duration is going to be 6 weekends. So if it starts 9th, 10th, we're going to go in 6 weekends. Thanksgiving is going to come up in the middle, so we are most likely going to take a break there, but we leave it up to the group. Every time last year we all took a break. A year before that we all took a break. So that's something that everybody appreciates, everybody wants. So it might go to 7 weekends because of the Thanksgiving. The timing is going to be 6 p.m. to 8:30 p.m. Friday and Saturday for folks in Pacific Standard Time or California or the West Coast. It's going to be 9 p.m. to 11:30 p.m. Sorry, this shouldn't be an AM, it should be a PM in the Eastern Time Zone. And it's going to be 6:30 a.m. to 9 a.m. in the morning for folks in India or the Indian Standard Time. So these are it's essentially the same time, but depending on which part of the world you are in, these are the timings to note for this training that starts next week. And most important question, how much does it cost? If you go to our website, we offer this course in $499, but for you all, you have taken the time out, attended this webinar, we are going to give you in a discount of $49 for that. And then if you decide to buy now, we're going to give you additional $100 discount. So if you think this course is something that is going to add value, speed up your learning, you can buy it. If not, you can. There's no need, no compulsion, no pressure to buy it. You can always ask us question in the email on ml@mcal.in. But the final price is going to be $350, and we have found this to be very competitive. If you go and look around, this is the most competitive price for the amount of information that you're going to get. It's all inclusive. There's no tax and any hidden charges in this. So if you think this is a course that is going to add value to it, in this $350, you're going to get live training, about 30 hours of live contact time with the instructor. You're going to learn Python. You're going to learn machine learning. You're going to do labs and homework. You're going to do project work. You're going to get handouts that you're going to read. So all this together with the recorded video of each session, you are going to get all of that in $350. It's a pretty good deal. And if you think you want to join our course next week, you can reserve the seat now, and you can reserve all this $149 of discount right now with just a $50 payment to reserve your seat. I will send out this link in the chat so that you can use it if you're interested to register for our course. There you go. I put it in the chat. And this is the point where I take questions. So our question from Shrikant is, do you help building resumes? Yes, we do help building resumes for folks and give them interesting inputs on how you should add the new machine learning capability that you have learned within your resume, how to position it. And we definitely give guidance on how to strategize and take your interview if your intention is to use this and apply for jobs. Can you also post the link to the 2 resources? Absolutely. You don't have to. So what I'm going to do is I'm going to convert this deck into a PDF, and I'm going to send it out. So you're going to get all this material with you. So all the 3 links that we had before, you're going to get that, Dipesh, okay? Any questions for you guys? This is the point where we can have questions, any questions that you have from the material that we shared. Is there anything that is hindering you or you think you're unsure of? Feel free to ask. I'm here to help you all. All right, I get a question in private. It says, I'm interested. What if I miss the course on a particular day or the lecture? What happens? Good question. So as you saw, we do a video recording of every session. So the session that you miss, you're going to get a video recording of that session. So even if you couldn't attend, but you'll get the whole recording of the session where all the other students attended. So that's going to be with you. And if you think that is not good enough, you can always join the same session in the next batch. So we don't give you any reason to miss out anything that you missed. So there will be ways to catch up. Anyone has any other question? Now let me ask a question. Is there what is the doubt that is coming in your mind that is stopping you from buying this course? If obviously machine learning is something that you want to learn and want to invest in, if that's something that you have as a strategic goal, what is the inhibition that is stopping you from going and taking this course? I would love to know. Nothing. So, I mean, everyone should be buying it. I'm just kidding. Anybody has any other question on the material? Anything? None? So, great. Thank you, guys. Thanks for your time. It was a pleasure interacting with you guys and teaching you a little bit about machine learning. I think it's an interesting technology. I think you guys have made the right choice of starting to peel the layers of the onion and understand what machine learning is. And today you took the first step in seeing what it is, and going forward, whenever you're going to read more material online or watch any videos, you're going to start making more sense of this technology. And I would like to wish you all the very best in your journey towards machine learning. I think this is the future. This is the technology that is going to change the next 50 years. And if you invest now, I'm very sure you are going to invest in something that is going to grow. So you're going to ride the curve and you'll be on the winning side of the curve. So all the best to all of you and wish you all the success. Thank you, guys. Have a good night, and thank you for giving me the time, taking the patience to hear me till 10 o'clock in the night on the Eastern Zone. Really appreciate it. Have a good night, guys. Sleep well. Yes, I get a quick question. I'm going to send out the recorded video and I'm going to send out the deck. It'll be there in your email in a day or two. It takes some time for me to process, so give me a day or two. You're going to have this information that we talked about in your inbox. So watch out for that email. All right. Thank you, guys. Good night. Have a nice night. Bye.